Hello, everyone. We are COVID-19 from Engineering Class 301. For our experiment design, we decided to test the advertisement claim of press and seal plastic wrap and whether or not it was really airtight and leak proof. My name is Jeremy Lane, and I will now introduce my fellow team members. They'll give you a polite nod and wave from their cameras. First, we have Cade. Next, we have James, Ryan, and lastly, Wesley. Next, I'd like to turn everything over to James, who will be going over the overview of what our presentation will be about today.
Thank you, Jeremy. Here's a brief overview. So covering the objectives, materials, and timeline, as well as the product selection, will be Jeremy. And then I will be going over the design considerations and trade-offs. And then it will be handed over to Cade, who will be doing the problem statement, the hypothesis, as well as the design relationship to the hypothesis. And then we will be going back over to Jeremy, who will go over the budget and experiment, as well as the internal and external variables. And then we each divided up the experiment steps amongst ourselves, and then finishing out the report will be Ryan and Wesley. I will now be handing it back over to Jeremy.
Thank you, James. So before we could really decide on what experiment we needed to do, we came together as a group to really compile our resources and see what we could feasibly do for this class. The bottom line was pretty clear. We wanted to do this as cheap as possible as we are poor college students. Take a moment and consider what kind of variables and limitations affected your design choice. Thank you. So for us, we decided that the budget should be minimal, that the items and resources we have available to us should be used first and preferably not bought or picked up. We needed to meet assignment objectives and due date, as well as also follow the time constraints selected by our group, which was to complete all assignments at least 24 hours before the deadline. And lastly, we needed to continue to adhere to our group's charter and objectives. Next slide, please. With these limitations in mind, COVID-19 selected the GLAD press and seal airtight and leak-proof test. So we now needed to develop a hypothesis and an experiment to test this theory and whether or not it was truly airtight and leak-proof. I'd like to pass things back over to James, where he will talk more on this.
Thank you, Jeremy. So we as a group decided to come up with 3 potential design considerations. The first one being a manometer, which is mostly used in measuring changes in fluid height. With that, we can then calculate other things such as pressure. For the second one, we decided to come up with like a vacuum apparatus in which we attach a shop vac to a trash can that has been sealed with press and seal. And then for the third potential design consideration, we decided to come up with sticking a pressure gauge inside of a vacuum that has been sealed with press and seal. I will now be going over the design trade-offs. So for each design consideration, there are obviously pros and cons. For the manometer, a pro would be that a volumetric measurement is easily transferable and could calculate things such as pressure, which is what our goal was for. However, there was a con with the manometer that any sort of exposure to air or leak in the system could lead to a false reading. For the second design with the vacuum apparatus, the supplies were readily available. You could get them at practically any department store. However, the con with such a large air vessel with the trash can, it would be tough to not only seal it with the press and seal, but with a vessel that big, you could introduce multiple outside variables. And for the third design consideration, the pressure gauge, it would give us a precise reading on the pressure. However, such a precise measuring pressure gauge would probably be hard to find for us college students because of a financial limitation. I will now ask the audience which method you guys decide would be the most practical based on your limitations. Thank you. As a group, we did decide to go with the manometer, and I will now be handing it over to Cade.
All right, thank you, James. So the core problem statement for this assignment is testing the validity of the marketing claims. So the goal is to very much focus on the airtight and the leak-proof aspect of it. And so to test that hypothesis, we are mainly just checking if can it hold a seal for an extended amount of time. And if it's able to do that, it does confirm that the advertising claims are correct. The group essentially agreed that it's a lot of marketing and that the product would not be able to achieve that goal. Feel free to respond on the discussion boards if you agree with the hypothesis. All right, thank you. And so for the project design justification, again, to just focus on the airtight and the leak-proof aspect, we're testing for can it be held for 5 seconds, both vacuum and pressure. And so overall, if it can do that consistently, we can confirm that it can hold pressure and vacuum, and it is airtight and leak-proof. I will now pass off to Jeremy to cover the budget and experiment.
Thank you, Cade. So with our project design chosen and our hypothesis agreed upon, we went about to developing a budget that would outline our how much we would actually spend on this design. As you can see on the chart, the figure behind me, the press and seal itself was about $8. The yardstick was about $5. The dishes that we used to test were an additional $5, and the bulb pump itself was a total of $15. All in all, we managed to keep our entire group cost below $35. To put this in perspective, we did a little bit of research to see how much one of these manometers would cost if we just bought one offline. And we discovered that had we done it any other way, the YouTube and pressure differential gauge alone would have cost us around $210. Next slide, please. Now that we had made all of these decisions and bought our supplies, it was important to determine what variables we could control and what variables we couldn't control, or our internal and external variables. Some of the variables we couldn't control was the varying textures and for different dishwares. Plastics and ceramics do not necessarily have the same kind of textures that allow plastic wrap to hold them as well. It might not have been an airtight seal on our pump that we used. And lastly, the density of the water might be affected by the food coloring that we add. For the external variables, or the variables that we could control, the different proficiencies in plastic wrap, which after talking amongst ourselves, we managed to eliminate by having a standardized method for each of us to wrap each bowl. Another thing that we could control is the change in the length and width of the plastic wrap. We measured and made sure that every group member, when they wrapped their bowl, only had the same amount of plastic wrap to work with. And lastly, consistent measurement. Because we were using a barometer that was subjected to the human eye of where it fell on our yardstick, we made sure we used only the same 2 group members each time to measure where our inches of food colored water was. Next slide, please. With all these things in mind, COVID-19 assembled and put our experiment to the test. We went ahead, and first step was to take our plastic and ceramic dishware bowls and drill through them. We used a diamond drill bit provided by Wesley that had already been purchased for a different assignment for his work, and carefully drilled through each bowl to avoid shattering. Afterwards, we took a nozzle attachment for our hose and carefully screwed it into each bowl. This made each bowl airtight because after a couple turns, it could not enter any further. It could not get any more purchase on that bowl without shattering it. And next, I would like to pass things back to James to talk about step 2.
Thank you, Jeremy. So with step 2, it actually came down to group members sealing the 2 bowls, both the plastic and the ceramic. So we decided, because it was considered press and seal, we as group mates were tasked with sealing each bowl by only using a pressing method. And then we each decided that each member should only have 2 chances of sealing each bowl. So as a way of being consistent, each member had 2 chances per bowl. So that would be 10 total pressings for each bowl, which led us to 20 total data points. And I will now be passing it over to Cade for the step 3.
All right, thank you, James. So for the next step, we actually attached the dish to the pump using a T-connector and clear tubing. We used the hole that we drilled and then got everything basically connected as tight and as sealed as it could. That way it reduces the chance that that would be another variable affecting the experiment's results. I'll now pass off to Ryan for step 4.
Thank you, Cade. So the 4th step of our experiment was to take measurements. Each team member had 2 chances to wrap the plastic bowl and 2 chances to wrap the ceramic bowl. In order to measure pressure, we used the pump that was attached to the bowl to push air into the bowl. And to measure vacuum, we used the pump to pull air from the bowl. The water level on the manometer was measured after 1 and 5 seconds. And now I will hand it off to Wesley for step 5.
Thank you, Ryan. Step 5, we decided to record our data using an Excel spreadsheet for ease of data manipulation and data analysis. We used a series of columns as shown in figure 15, where we wrote down the trial number and material used for the bowl, the group member that recorded the trial, the result that we got for 5 seconds, and the result for inches of water column for 1 second. Next slide, please. And now I will pass it off to Ryan to go over the conclusion.
Thank you, Wesley. So originally our hypothesis was that the press and seal wrap would not create an airtight seal over the bowl. Overall, our team was able to design and conduct an experiment, also on a tight budget, that allowed us to collect accurate measurements about the levels of pressure that the press and seal wrap could hold. Looking at figure 16, we can see that the average inches of water held by the plastic bowl are 0.375 and 0.638 inches for 5 seconds and 1 second, respectively. And the averages for the ceramic bowl are 0.325 inches for 5 seconds and 0.725 inches for 1 second. Now, I'd like to give you guys a few seconds to look at these numbers and come to your own conclusions about whether or not our hypothesis was true. So, although the values of these numbers are pretty small, we can still conclude that the press and seal wrap created an airtight seal over the bowl, which is a contradiction to our hypothesis. And additionally, since 2 different bowl materials were tested, we can also infer that the press and seal wrap is able to work on multiple surfaces. And now I'm going to pass it off to Wesley for the experiment improvement section.
Thank you, Ryan. For possible design improvements, we thought that replacing the pump would be an excellent improvement. During our experiment, we found that the pump itself had a minor air leak and lost air at a steady rate. Even though we had this issue, we still accounted for this air within our calculations. But it would be a drastic improvement to know that our system is in fact a perfect seal. The issue was within the valving inside the pump. So I think buying a more specialized or possibly even a more expensive pump would improve our results, but might cost more money, which would be a potential drawback. Now I would like to ask the audience to please use the discussion board and list a possible design improvement that you guys might have for our design based off what you've seen. So I'll give you a moment to list them out. Thank you for listing your possible design considerations. Now we move on to the result comparison. The literature that I was able to find on previous studies was conducted by teachbesideme.com, where they conducted an experiment with Glad Press and Seal to test whether it's able to hold water, rocks, marbles, and rice in an upside down orientation without breaking the seal or leaking. In their experiment, they found that it was in fact able to hold water, rocks, marbles, and rice, which coincides with our conclusion that the Glad press and seal is in fact airtight and leak proof. Figure 17 displays how they set up their experiment. And now we move on to the question and answers portion, and we would like to open the floor for any questions that you guys might have on our presentation. All right, thank you for your questions. This concludes our presentation, and we would like to thank you for your time and listening to what we have to say.